So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is divide an array into subarrays with minimum cost part 1. So you are given an array of integer nums of length n. The cost of an array is the value of its first element. For example, the cost of this array 1 2 3 is 1, while the cost of this array 3 4 1 is 3, because 3 is the first element and 1 is the first element. Now you need to divide nums into 3 disjoint contiguous subarrays. In the end, you need to return the minimum possible cost of these subarrays. So what the question is saying that let's say you are given an array something like this: 10 1 2 3 4 5. Now you need to make cuts such that this array divides into 3 parts, and the sum of the cost of these 3 parts should be as minimum as possible. So let's say we put a cut here and we put a cut here. So you can see this array is divided into 3 parts. So the first part has the cost of 10, the second part has the cost of 2, and the third part has the cost of 4. Because in this subarray the cost will be 10, in this array the cost will be 2, and in this array the cost will be 4. So 10 plus 2 plus 4 will be the final cost, or the sum of the cost for this particular partition. So we need to minimize this cost. We need to minimize this sum of 3 cost. So this is what the question is saying. Now how we can minimize the cost? So one important observation in this question is that wherever you put the cut, either here, this will be surely included in the sum of the cost. Why? Because let's say if you put a cut here and if you put a cut here, so first array will be this only, right? Let's say if you have put some other where cut, you have put a cut here and you have put a cut here, so this will be the array, and for this array the cost will be 10 only. So you can see that you do not have the control. You don't have the control over this first subarray's cost, because wherever you cut, it will, the subarray that will be formed, the first subarray will be formed, it will include the first element. So this first element will always be included in the answer, and we cannot neglect this, or we cannot remove this, or we cannot minimize this part. So this will be surely in our answer. So what we can say, our answer will always have the nums of 0 in our answer part. Now we don't have control over this particular value. We can only control the other 2 values. So what I am saying that, let's say this is the same array, 10 1 2 3 sorry for that, yes, 3 4 and 5. Let's say this is the array. Now it is sure that this element will be included. Now we need to make sure that the cuts we make either here or somewhere else, the other 2 values, let's say these are the 2 values, because if we make cut here, this will be the first subarray, this will be the second subarray, and this will be the third subarray. We have control over these 2 values. So these 2 values should be as minimum as possible. So this is what we need to do. So we do not have the control over the first value, but we have the control over the other 2 values. So we should make sure that the other 2 values are as minimum as possible. And how do we find the other 2 values should be as minimum as possible? So let's say this is the 0 index, 1 2 3 4 and 5. These are the index of the array. So what we can do, we can find first minimum and second minimum in this array part, because this value will always be included in our answer, and from this part we will find the first minimum, or the minimum value possible. You can say minimum possible, and the other value should be second minimum possible. So second minimum possible, we will find the minimum value possible. In this case the minimum value is 1, in this case the second minimum is 2. So we will make sure that we make a cut such that one subarray will have this value 1 as the first element, and one subarray will have the value 2 as the first element. So how we can do that? We can do that by making a cut here and making a cut here. So this value will always be in our answer. So this value is always be in our answer. So 10 plus this is the minimum value and this is the second minimum value. So for this array this will be the first element, so +1, and for this array this will be the first element, so +2. So you see we had the control over these two elements, so we pick the minimum and second minimum value possible. So if you have put anywhere cut anywhere else, so it will just increase your cost, because you are replacing these elements with some higher elements, so obviously your cost will increase. So one way is that you can take these set of elements, you can just sort them, and after sorting take the first index and the second index value and add them with this particular answer. The second way is that you can do in the single pass. So let me show you what I am saying. So this is the code. So you can see that I have declared an integer n. So this is the first way of doing with the help of sorting. So this is the first way by which you are doing with the help of sorting. So n is the size of the subarray. Obviously nums of 0 will be always included in our answer, and from the nums.begin +1. So let's say this is the array. So these are the elements 10, 1, 2, 3, 4 and 5. So nums.begin +1 means start your array from here and go till the end. So take this part of the array, and sort it. So after sorting, in this case it is already sorted. So after sorting, in the entire nums array, this part will be sorted, and this we have already included in our answer. So from the sorted part we need to take the first and second value, right? So first and second value in this sorted part will be what in the entire nums of 1 and nums of 2. So this is nums of 1 and this is nums of 2. So we are just adding it into our answer and we are returning that. So this was about the sorting part. So sorting would have taken n log n, but we actually don't require sorting here. We can do it in single pass with the help of O of n approach also. So let us see how we can do it in the O of n approach. So obviously in this case also the answer will have the first value included, so nums of 0. Now from the first index to last index to n-1, we need to find the minimum value and second minimum value. So we need to find the minimum value and second minimum value from this first index to n-1. In the sorting part also we were doing that only, but we have sorted the array, so it would have added the time complexity of n log n. But here without sorting also we can do it in O of n approach. So you can see we are just running a single loop from one index to less than n, that is n-1. We are checking, we are initially declared two variables, mini and second mini. This will take care of the minimum element and this will take care of the second minimum element. So we are checking if the nums value is less than the current minimum value. So if it is lesser than the current minimum value, that means we got a new minimum value. So we are updating our minimum value with this nums of I. Now the previous minimum that we had will now become the second minimum. So we are just updating our second minimum with the minimum value that was previously. So this was one case. What can be the another case? Another case can be that you got a value which is lesser than the second minimum but greater than the minimum. So in that case you just need to update your second minimum part. So if the nums of I is lesser than second minimum, just update the second minimum value with the current nums of I. In the end, whatever the answer you had, the nums of 0, add minimum and second minimum to that, and in the end return the answer. So this is what we are doing. So this is a single pass solution, single pass O of n, and the above part, that above solution that we saw, it was a sorting based approach that would have taken O of n log n. So this is how we can solve this particular problem. So I hope you understand this solution. Thank you for watching.